Good morning to all of you. I am Pravesh Rashish and we are discussing the new experiment that is Ohm's law. And we have to find out the value of resistance with the help of this Ohm's law. This is basically a circuit analysis of Ohm's law. Here we have taken battery. For the battery we have taken the battery eliminator. Battery eliminator. The positive end of this battery eliminator connected with positive terminal of voltmeter. The negative terminal of voltmeter is connected with positive terminal of ammeter. The negative terminal of ammeter is connected with key. And the next terminal of the key is connected with rheostat. That device is known as rheostat, RH. The resistance wire, whatever we use, is parallel to the voltmeter. Okay, so this is basically a circuit analysis of Ohm's law. Here we have taken the least count of the circuit. Least count means what? The minimum reading that a circuit or an instrument can acquire. Okay. First of all, we have taken the least count of voltmeter. That is, formula of least count is range upon number of divisions. Okay. What do you mean by range? Range means the maximum value the substance or a device can measure. Okay. So in our circuit, in a voltmeter, the maximum value is 5 volt. Means it can measure the value up to 5 volt. Okay. So we have taken here 5 volt as a range upon the number of division. The number of division in the voltmeter has. Okay. In number of division we have 50 division, so that the least count of voltmeter is 0.1 volt. 0.1 volt means each indicator or each interval of the voltmeter having the value of 0.1 volt. Okay. On the same basis, we have taken out the least count of ammeter. Okay. And the same formula we have used, that is range upon number of divisions, which is 5 ampere upon 50, because the maximum value of the current that has to be measured is 5 ampere upon the number of division, that is 50. Then it comes out to be 0.1 ampere. Okay. Whatever the table we have considered, first of all we have taken out the range of V1, V2 and V3 and I1, I2 and I3. According to Ohm's law, V is equal to IR. Therefore, V by I is equal to R. Okay. This means that we have to take the value of voltage upon current in the ratio, so that this ratio will give the resistance of the wire. Okay. So we have taken 3 readings here, V1, V2 and V3, I1, I2 and I3, and corresponding to which we will get R1, R2 and R3. How can we get it? R1 is equal to V1 by I1, R2 is equal to V2 by I2 and R3 is equal to V3 by I3. That's the value. Okay, and we have taken out the mean of that resistance. That means R mean. R means what? R1 plus R2 plus R3 upon 3. That will give the value of resistance of that wire. Okay. Now we have started. That is basically an arrangement of the Ohm's law. Here we have considered voltmeter, ammeter, one-way key, rheostat and battery eliminator. Okay. So here we have considered, that is battery eliminator. Battery eliminator is a device which is used to convert 220 volt AC into 0, 2, 4, 6, 8, 10 and 12 volt DC. Okay, that is a battery eliminator. This eliminator works as a rectifier for the circuit. Okay, this means that rectifier is a device which is used to convert AC into corresponding DC. Okay, so we have taken the positive terminal, the positive knob, that is plus, and the negative knob is minus, that is black. The red knob is plus and the black knob is minus. Okay. We have considered a circuit in which positive terminal of the battery eliminator is connected with voltmeter, that is positive terminal of voltmeter. the negative terminal of voltmeter is connected with corresponding ammeter, that is positive terminal of ammeter. Then the negative terminal of ammeter is connected with one-way key, that is one terminal of one-way key. The next terminal of key is connected with rheostat, that is a device which is used to vary the resistance or vary the current. Okay, that is known as rheostat. Okay, so we have considered one terminal. The next terminal of key is connected with one upper part of the rheostat. The lower part of the rheostat is connected with the negative terminal of the battery eliminator. In the circuit, we have given that the wire, that is resistance wire, is connected with parallel to the voltmeter. That's why we have considered, see, that is a resistance wire which is connected parallel to the voltmeter. Okay. Now we have started our experiment. Here we started the switch. Here, as you see, the indication of power here, that is power is on. Okay. Here we have given the range of current and voltage. हम यहाँ पे रिओस्टेट की वैल्यू आगे पीछे करेंगे तो आपको दिखाई देगा रेजिस्टेंस, वोल्टमीटर एंड एमीटर की रीडिंग करस्पॉन्डिंग वेरी होगी। यहाँ पर हमने इसकी वैल्यू वेरी करी। जैसे हम यहाँ पे वैल्यू इसकी वेरी करेंगे, आप देखेंगे वोल्टमीटर और अमीटर की रीडिंग कंटिन्यूसली वेरी हो रही है। इस वैल्यू को हम जब लेंगे, इसका रेशो लेंगे, हमने कोई सी भी 3 रीडिंग हमने यहाँ पर ली और उसका जो रेशो लेंगे वो R1, R2 एंड R3 होगा। सपोज वी हैव टेकन हियर द इंडिकेशन हियर, सो इन दिस इंडिकेशन वी हैव कंसीडर द वैल्यू ऑफ एमीटर इज 0.5, okay, and the value of voltmeter is near about 0. So we have move out that voltmeter. See, the indication is here, voltage is 0.5 and corresponding reading of ammeter is optic. Okay, so we have taken the ratio of V1 and I1, V2 and I2, V3 and I3. That gives the resultant of R1, R2 and R3. That R1, R2 and R3 is the resistance of wire on the different position of the rheostat. So on taking the mean of that resistance, we will get the value of resistance of the Ohm's law.